Welcome to topic number 22 in Richard James Mathematics Resources. This one is entitled Straight Line Graphs. In this topic, we will be taking different approaches to drawing the graph of a straight line. The simplicity in graphing a straight line lies in its lack of variableness. Because of the constant direction, a straight line can be graphed as soon as we have found 2 points through which it passes. It is true that 2 points will fix the direction of a line. However, there is no perfect mathematician, and sometimes mistakes are made that are not easily detected. To capture the mistakes, an error-correcting third point is introduced. If the line passes through the 3 points, then we are okay. If not, the 3 points are recalculated until the culprit is found. So we have to calculate the points again until we find the one that is out. Or probably 2 of them would be out, so we could eliminate 2 of them. But to include a third error-correcting point is always a good thing. It is not always necessary, and we might find that there are circumstances in which when we determine the 2 points through which the line passes, then we are 100% sure that we are correct. As we shall soon discover, the approach taken to graphing a line should be dependent on how the equation is expressed. There are some ways that lines are stated that when the 2 points are found, no error-correcting point is needed. The easiest line to graph may well be those of the form 2x plus 3y is equal to 12. These have the x and y terms on one side of the equation, and it is usually the left side of the equation that the x and y terms are on. These are probably the easiest lines to graph. There you have, it is highlighted, the 2x plus 3y. Those are on the left-hand side of the equation, and that makes it easy to graph the lines. And also, of course, the constant value is on the right. From the appearance of the equation, causing the x-ordinate to be equal to 0, the associate y-ordinate can be found quite easily. So we have our equation right there. And of course, we are substituting 0 where we have x. So we are causing x to go to 0. So we're going to solve that equation that remains. Notice that if 2 times 0, that is going to be 0. So on the left-hand side, we have 3y is equal to 12. So y is equal to 4. The coordinates of the point will be 0, 4. Remember that the x-ordinate is equal to 0. We cause it to be equal to 0, and the y corresponding y value will be 4. And there we have it. Although we do not have a grid on which we have the numbers given from 0, 1, 2, 3, 4. We are just giving an indication because we do not really need a grid to draw this graph. The x-ordinate being equal to 0 means that there is no movement in the x direction, and the point will be 4 units on the y-axis. So the point is 4 units on the y-axis, although we don't have the units shown there. We know that we're going to have that anyway. So we're going to cause the y-ordinate to be equal to 0. And if we do that, what will happen? Right. So that is our original equation. 2x plus 3y is equal to 12. So we cause the y-ordinate to be equal to 0. So all we have is 2x is equal to 12. And we solve that. And of course, we are going to mark on the x-axis position 6. So we will place this point on the x-axis where x is equal to 6. So we're going to choose right there. And do not forget that we are not going to be using a grid, because we can just say that position is 6 or that position is 4. When the point requires a greater level of precision, then we'll go that route. So the exercise may be completed by drawing the straight line that passes through the 2 points. Right? And that is your straight line. And of course, you're always going to be sure that that is going to be the correct answer. replace the x value with 0 in the other equation. So we have another equation that we are going to be using to graph also. We have 5x plus y is equal to 15, and of course we are going to equate the x value to 0 and see what happens. So 5, 0 is 0, so all we have is y is equal to 15. So y is equal to 15, so we are going to put on a graph where y is equal to 15. So there we have it. And then we are going to cause the y ordinate to be equal to 0 also. So that is what we are going to have. And 5 plus 0, 5x plus 0 is going to be equal to 15. So 5x is equal to 15, x is equal to 3. So as I stated before, the earlier topics like solution of linear equations and those topics that were done earlier on, it is very important that students understand those topics, because the information that we have gathered from those topics will be used time and time again. So x is equal to 3. So there we're going to have that point, and it's going to be on our x-axis like that. So draw the line through the 2 points. So there we have it. These lines are quite popular when working with linear programming, topic number 30. And it's going to be important to remember the information that we have here, because it's going to make life a lot easier if students are aware of these facts that we are presenting here as soon as we get to the other topics. Graphing a line in this manner will be proven to be quite beneficial when studying linear programming. It is not a complete necessity to use a grid in order to demonstrate the construction of these lines. So here we're going to graph another line. Here's another form of the equation of a straight line. Y is equal to 4x, or y is equal to x over 2. So we have y on one side, x on the other side, and we do not have a constant value. So we may graph those lines also. Let's see how easy we can graph a line that looks like that. So y is given in terms of x, and there is no constant. The simplest approach in this case is to assign values for x and determine the corresponding y ordinates. So we have y is equal to 4x. What we have done there, cause x to be equal to 1. So if x is equal to 1, y is equal to 4. So the first point is 1, 4. So remember, we have expressed here, here is your y is equal to 4x. So we are going to cause the x value. We're going to put an x value. We are going to say x is equal to 1 and see what y is equal to. So y is equal to 4, so the first point is 1, 4. So we are required to choose another point. Y is equal to 4x, that is the same line that we have. Say 2, so y is equal to 4 times 2, so y is equal to 8. So the other point is 2, 8. So we're going to plot that point also. Right. Of course, we may draw our straight line because we have 2 points. When x is equal to 0, 4 times 0 is equal to 0. So the coordinates will be 0, 0. This implies that the line will pass through the origin. So the line will pass through the origin, and we have that as a point also, a positive point. And that is our line. Now, there is no rule governing the values of x that you will choose. But what you can do is look on the scale that is given when you are required to graph the lines. After examining the scale, it will give you a good indication of the possible x and y values that you may be able to obtain from the graph. And you are going to choose your value of x in such a way that when you plot the point using the x and y values, that the point will also be on the grid. So you cannot choose values of x and y that will give you, especially like in this particular case, that will give you an y value of 35 or 36 or 100, because you do not have 100 represented on your graph. And if you choose 3, but in this particular case, 3, 4 is 12, therefore that point will not be on this grid. So you just have to choose points that will be on the grid based on the scale that you have. And appropriately the way that you have created the axes and the values that you have represented on the axes also should play a very important role in deciding the values of x that you use. It is upon the students to choose convenient values of x. Note also that although only the positive values are shown, the line may extend as far as the situation dictates. This may include negative values also. So here's another one. What is our new equation? Another equation right there. Y is equal to x over 2, or y is equal to a half of x. Sometimes it is written like that, or y is equal to a half of x. So we are going to use the next equation, which is this one, and then we are going to say, let's say the value of x is equal to 8. What happens? Y is equal to 4. So the point is going to be what? 8 for the x and 4 for the y. Right here we have x over 2, or we can say half x. That means you are sure already that whatever the x value is, y is going to be half of it. So you're going to plot that point right there. Choose another x value that is a multiple of 2. Usually you use that because you don't want to introduce any fraction unnecessarily. You have a lot of options and yet you only need 2 points. And of course you may include an error correcting third point. So you don't need to use values that will give fractions. So what are you going to choose? Choose 4. So y is equal to 2. So your point is x is 4 and y is 2. And you have it right here. 4, 2. So you know that you're going to go for the x 4 and then you do 2 right there. Just like it was demonstrated when we were looking at quadratic graphs, that's the same process that we are following. When x is equal to 0, of course 0 divided by 2 is equal to 0. The coordinates will be 0, 0. The line will pass through the origin also. So that's another line through the origin. And of course we may draw our line like that. And that is how easy it is to graph those lines. After this exercise, students should find graphing lines generally easy because you're going to choose a method that is suitable to how the equation of a line is presented. So multiples of 2 are chosen for the values of x in order to avoid using fractions. We only need 2 points, so introducing fractions is just not necessary. Of course, we are continuing to graph straight lines, and now we have one, y is equal to 2x minus 5, which is the maximum level of difficulty with the exception of the fact that we may have a fractional coefficient of x and also fractions as our constant that we have there instead of a negative 5. The appearance of this equation is similar to the one in the equation in the quadratic graphs. The table can therefore be constructed. No range of values of x is supplied, so let us use some values convenient to us. So there we have it. We have some values of x. So let us do it the same way that we work out the figures in the quadratic graph. Now we have 2x. So what does 2x mean? It means that everything that we have here in our x row, this is the row that contains x, the values of x. So we have 2x. That means everything here will be twice x. So we're going to have a negative what here? Negative 8. And we're going to have twice negative 2, which is a negative 4. And twice 0 is 0. Twice 2 is 4. And twice 4 is 8. Now this negative 5 is a constant. It's going to be negative 5 all the way through, as usual. So the constant value of negative 5 is to be inserted in the other row. Constant means it's the same thing throughout. And then how do we determine the value of y? Negative 8 minus 5. So we're going to add all the values of y is going to be determined by working with these. So we're going to say negative 8 minus 5 and it will go there. That is a negative 13. Negative 13 goes there. Then of course these two. Negative 4 minus 5. That's a negative 9. Goes there. 0 minus 5 and negative 5 goes right there. So we have 4 minus 5, that's a negative 1. It goes right there. And of course 8 minus 5, that's a 3, and it goes right there. Do not forget that when we are going to determine the values of y, that the numbers in the first row are not included in our final calculation. Our final calculation is dependent on the rows that have the equation. So we have 2x minus 5 right here. We have y is equal to 2x minus 5. So 2x is there and negative 5 is here. So these are what we are going to use to determine the values of y. So these two will be used, and the numbers in the first row will not be used. 2 points are needed in order to graph the line. It is best if we use points that are far apart. This will increase the accuracy of the drawing. An error correcting point may also be introduced. The slides do not provide us the capability of using the furthest points. So we are going to be using the points that we have right there. 0, negative 5, 2, negative 1, 4, 3. How do we get that? We know that we have 0, negative 5 right here. So the x value is 0, the y value is negative 5. In the other instance, we have 2, negative 1. So the x value is 2 and the y value is negative 1. And here we have the x value is 4 and the y value is 3. So those are the points that we are going to use. So we are going to graph another one. Draw the graph of the straight line y is equal to 2x over 3 plus 1. Of course, notice that we did not go to the graph of the line immediately. That is because we are going to work out another straight line and we are going to graph both of them together. So it's not that I've forgotten that we need to graph a line. We are just going to work out the other one and we are going to put both of them on the same grid. Right. Now the x values are strategically derived right here, the values that we're going to be using. And what is the strategy? We are dividing here by 3. So that is why we use negative 3 here. So we can have something to be divided by in order that we do not get a fraction. Notice that the coefficient of x is 2/3. We have it right here. So the coefficient of x is 2/3. This presents us with the need to divide by 3. Since we need only 2 points, we may use only the multiples of 3 in order to calculate whatever we are doing. Right. So we do not need to put anything else in the table. We just need to concentrate on the columns of the table that has something. When we divide by 3, we do not get a remainder. So if we divide negative 3 by 3, we are going to get negative 1. And we're going to take negative 1 and we multiply by 2, we get negative 2. Here, we take 0 and we divide by 3 and we get 0. So we multiply 0 by 2 and we still get 0. Here, what do? X is 3. So 3 divided by 3, the 3's are gone. So we are left with 2. So 2 is what we have right there. The positive 1 is a constant value and it's going to be there, there, and right there. So no problem with that. So we can calculate now the values of y. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. And 2 plus 1 is 3. So there we have it. Negative 2 plus 1 is equal to negative 1. It goes there. 0 plus 1 is 1. It goes there. And of course, the other one, we have stated how we have calculated it already. We can afford to leave out quite a few of the values only because we are dealing with straight line graphs. Conveniently leave out the values that will give fractions. So here we have the two straight lines graphed. On the left, we have the two straight line graphs. When graphing straight lines, an examination of the equation should give a good idea of the approach that is to be taken. Keep an open mind and use your common sense along with the techniques that you have learned in order to simplify the process.